Alright, so I haven't done a lot of Physics 2 problems yet. I talked a little bit about E&M, but basically what happened was I had someone ask a question, specifically this one, so I figured I would go ahead and talk a little bit about it, even if I haven't talked about the concepts yet on this channel. That's something that could happen here soon. But for now, let's go ahead and work through this one. If you're familiar with it, great. If not, I'll try to explain it to where we would all still understand what's going on. So we have these three charges placed at the ends of this triangle, and it wants us to find the net force acting on all the charges. So we have a charge here, charge here, charge here. The distances are all the same. It's an equilateral triangle. And on top of all the sides being the same, another thing we know is that all these angles are the same. And each angle is 60 degrees. Cool. Now let's go ahead and work through everything. We're going to start with the force on Q1. Okay? And what we're going to want to do is break this up into components because we have a force acting in the X and Y direction. So it doesn't really matter which one we start off with, but in this case, we'll do, I guess, the X direction. So X direction. We draw that a little straighter. So we have the sum of all forces on particle 1 in the X direction. And that's going to be minus the magnitude of force 2 onto 1. So if we look at charge 2 here, in fact, let's draw a free body diagram. So for Q1, free body diagram. What do we have? Well, this is the force 2 exerts on 1. And this is particle 2. Now, charge 3 comes at an angle, right? They're all like charges, so this is going to push it away. That's going to push it away. Now, what angle is this right here? Well, if we were to put this free body diagram here, I think we would see that this angle is opposite this angle. So if this is 60 degrees, and we know all of this is 90 degrees, this angle inside must be 30 degrees. So we have all of the force that 2 exerts onto 1. We also have to take away from that the X component that charge 3. This is 3 onto 1. Also exerts onto 1, which would be F3 onto 1 in the X direction. It also has a Y component to it. So sum of all forces in the X direction. This we can just do as minus K Q1 times Q2 over the distance squared. So this is Coulomb's law. This is the, if you're not familiar with this, for these charged particles, the force is equal to K constant times the charge that's actually being felt times the charge exerting the force divided by the distance between them. The R hat's just implying it's a vector, which it is. So we can just take the magnitude of it, which is what we did for 2, because it's all in the x direction, minus k q1 q3 divided by d squared. And what do we want to do? Well, we just want the x component to start. So that's opposite. So we would say sine of 30 degrees. Now that we have that, we can simplify this a little bit and say sum of all forces in the x direction. Well, they all have a k, they all have a q1, they all have a distance squared. So I'm going to factor all that out, and I'm left with q2 plus q3. So sine of 30 degrees. Sine of 30 degrees is what, root 3 over 2? Yep, root 3 over 2. And before we move on, I'm going to go ahead and we're going to do y direction over here next. But I'm going to go ahead and plug in these numbers. So k, we have negative 9 times 10 to the 9th, that's our k constant, times charge 1, which was 2, it's a micro coulomb, so that's 2 times 10 to the negative 6, all divided by the distance, so we need to convert 3 centimeters to 0.03 meters, we square that, times the charge for 2, which is 3 times 10 to the negative 6 microcoulombs. Let me make sure I'm plugging this all good in my calculator. Plus four times 10 to the negative 6 microcoulombs times the square root of 3, all divided by 2. And we get about minus 129.28, right? Did I do that? X direction is here. Yep. That's sine of 30. Sine of 30 is not root 3 over 2. I'm sorry, that's 1/2. Let me fix that. Minus 100. Sorry about that. I was about to say that's a very big charge. Minus 100. Sorry about that. Sine of 30 is not root 3 over 2, it's 1/2. So don't forget our basic trig. Okay, so with that in mind, sum of all forces of 1 in the y direction. Well, there's only one force, so it's minus F31y, right? 2 isn't acting in the y direction. If we look at our free body diagram, it's just 3. So we have minus k times q1 times q3 over the distance squared cosine of 30, because we want, sorry about that, my calculator was being silly. So once we plug all this in, you'll get about negative 69.28 newtons. So now we have the sum of forces in the x direction over here and the y direction over here. So this is that part. Now the magnitude of the force that one feels is the square root of fx squared plus fy squared. So that's a square root of about negative 100 squared plus negative 69.28 squared which ends up being 121.655 newtons. So that's one. Now what do we need to do? We need to do the force on Q2. So let's start by drawing a free body diagram. Again, just like how force Q2 was pushing back Q1, there's also a force that 1 is exerting onto 2. Okay? So that's this part. And then, so that's this and also this. So we also have this. And this is the force of 3 onto 2. Okay? Now we're going to work through it in the exact same way that we did over here. Just like we did with, where's our free body diagram? Just like we did here. So what do we have? We have, this is going to be our 30 degrees. And we can just do right triangle trig here, but some of it will be easier. So now that we have that, let's do our X and Y. So let's start with X direction. So the sum of forces of 2 in the X direction is going to be equal to F1 onto 2 plus minus, not plus, F3 onto 2. So what I want us to see is that this is a third law partner with this, which is pretty helpful. But in this case, let's just go ahead and work through it. So the sum of forces of 2 onto X, I should mention this one has Y components, so we're specifically looking in the X direction. K, Q1, Q2, over the distance squared, plus K, Q3, Q2, over the distance squared. And we just want the X component. So we're going to be looking at sine of 30 degrees. So this is the sum of all forces on 2 in the X direction. What we're going to do is factor out a K, Q2 over D squared. We're left with Q1 plus Q3 divided by 2. So if we just plug this in, let's see. You will get 120. Equals 120 newtons. But we're also interested in the Y direction. So let's analyze that. Well, the only force in the Y direction onto 2 is the force of 3 onto 2. Okay? The force of 2 in the Y direction is going to be K, Q3, Q2, divided by the distance squared. And if we look at our free body diagram, we're going to want cosine of 30. which is 2 root 3. So if you plug all this stuff in, you should get about negative 103.923. And just like before, we'll say that the sum of all forces, we'll just say the net force, we'll do this. The magnitude of the forces on 2 is going to be F2x squared plus F2y squared, which is square root of about 120 squared plus, it'll be a positive, so 103.923 squared. And if you plug all that in, you should get, let's see what we get, 158.75, about 158.75 newtons. So we found the net force on the 1 and 2. Now we just have to do for Q3. So let's look up at Q3. Q3 is going to be repelled by 2 this way and 1 this way. So let's see what that free body diagram will kind of look like. We have the force of 2 onto 3 and the force of 1 onto 3. Now, if we were to go here, let's look at the graph. That's not what I wanted to do. If we were to go like this, and to make another triangle here, what angle would this be? Well, it's going to follow, well, let's see. This, right? This should be what? Looking at it. Well, this is going to go right up the middle. So this is actually going to be the 60. So that means we're going to be working with the 60 degrees. Okay? So that's 60. And this is 60. These are 30. It's 60 total, which is what I was talking about earlier. If this is 60 degrees, then this is the same angle. Okay? And it needs to add up to be 180. So there you go. So now that we have that, hopefully that makes sense. We know this is 60, and we know 60 times 3 gives us our 180, so they both have to be 60. Okay, so with that being said, we know these angles. This is 60. This is 60. And we'll do the same thing. We'll look in the x direction first. And what do we get? So the sum of forces for 3 in the x direction is going to be the force exerted by 1 onto 3 plus the force exerted by 2 onto 3. Now 1 will be positive, 2, sorry, I was about to sneeze, 2 will be negative because of the direction it's going. It's shooting off this way. So 1 onto 3 will be K, Q1, Q3, all over D squared. Let's see, it's going to be, we want this part, so we'll say cosine of 60 minus K, Q2, Q3 over D squared, also cosine of 60. So the force of 3 in the x direction, let's see, they all have a K, they all have a Q3, they all have a D squared, cosine of 60, so cosine of 60 is 1/2. Hopefully I didn't get that one wrong this time. So this is 1/2, this is 1/2, I'll factor that out. And we're left with just Q1 plus Q2. And before we get to the y direction, oops, this should be a negative. There we go. Before we get into the y direction, let's go ahead and plug in our numbers. 9 times 10 to the 9th times Q3, so that's 4 times 10 to the negative 6, divided 2 by 0.03 squared, times 2 times 10 to the negative 6, minus 4 times 10 to the negative 6. This is negative 40. Negative 40 newtons. Which makes sense. Just conceptually, we know the charge on 2 is stronger, so it's going to repel further, so it should be negative. Right? So, now that we have that, we can do the exact same thing in the y direction. And let's see, they're both positive. So let's see what we get. So we'll do K, Q1, Q3 over D squared. And we'll do sine, because we want this. That's not what I wanted. Sine, because we want the y component, so opposite. Sine of 60 degrees is root 3 over 2. So I'll just put that right here, times root 3 over 2. I'll actually just put the 2 right here, because that'll all be factored out. Plus K, Q2, Q3, D squared. It also has the sine of 60. So, factor some stuff out to make our life a little bit easier. What can we factor out? How about a K? How about Q3? 2 times the distance squared. Can factor out a root 3. And it's just Q1 plus Q2. All right. So, let's see. So real quick correction. When I was plugging these numbers in, I was plugging in the wrong Q. I was plugging in Q3 instead of Q2. So that changes this to negative 20. And then this became 173.205 newtons. Again, this is still negative, so it's okay. This is positive, which it should have been. So now that we have this, the force of 3 is the square root of 3x squared plus f3y squared, which, when you plug in, is about 174.356 newtons. So this is the force that 3 feels, the net force 2 feels, and the net force 1 feels. So sorry about the little trig error, and also I plugged in the wrong charges there. But this is the way to do this. You look at your triangle, you make a free body diagram for each particle, and then from there you use Newton's second law, you use Coulomb's law to describe the forces, and then it's just a little bit of math, so not too bad, right?